Hello student, myself Millie Sankla, and in today's session we solve the example of column and strut in our subject structure analysis part 1. Okay, now we start with our example. First of all, read the given data before solving 2.5 meter long pin-ended column subjected to square section is made up of timber. Using Euler's formula, find out size of column. Okay, here we find out size of column, that means data is not given, with factor of safety 2 and load is given 250 kilonewton. Consider E is equal to 12.5 gigapascal and axial stress in axial compression is equal to 12 megapascal. Okay, here size of this square section is not given. Suppose here we assume this is B and this is B. One by one, length L is given. L is equal to 2.5 meter. Okay, write down 2.5 meter. Convert into mm. 1 meter is equal to 1000. So 2.5 meter is equal to 2500 mm. Okay. Next, load P is given. P, that means here safe load is given. P safe is given 250 kilonewton, and that is equal to 250 then 10 raised to 3 newton. Okay, and FOS is given, factor of safety is given 2. Next, Young's modulus E is given 12.5 gigapascal, 12.5 gigapascal. Okay, and 1 gigapascal is equal to 10 raised to 3 newton per mm square. So convert here 12.5 10 raised to cube newton per mm square. Okay, and next data. Okay, now one by one we solve the find out the size. Okay, here we find out two size, for first for this and second for this sigma 12 megapascal. Here stress is given sigma 12 megapascal. Okay, and this 12 megapascal, that means 12 Newton per mm square. Okay, 1 megapascal is equal to 1 megapascal is equal to 1 Newton per mm square, and 1 gigapascal is equal to 10 raised to 3 Newton per mm square. Clear? Now one by one we find out here. Okay, now first of all, long 2.5 meter long column pin ended, that means write down here both end of column. First find out effective length. Both ends of column are pin ended. Okay, pin, or we can say hinge. So here LE is equal to L, that is equal to 2500. First we find out this length. Okay, now second, here safe load given. What is the equation of FOS? FOS is equal to, because we find out this size with respect to this Euler's formula. Here we write down Euler load. Okay, PE divided by P safe. Now one by one, FOS is given 2 and PE we find out, and P safe is given 250 into 10 raised to 3. Ultimate, my PE Euler load is equal to 250 into 2 into 10 raised to 3, that means 500 into 10 raised to cube Newton. Clear? Okay, here we find out effective length, then we find out our Euler load. Now next turn we find out moment of inertia. Okay, here square section is given. What is the moment of inertia of square section? It is equal to B raised to 4 by 12. So right here moment of inertia I is equal to B raised to 4 by 12. Now one by one here we find out the size. What is the equation of Euler load? Right here Euler load is equal to PE, and this PE is equal to pi square EI by LE square. Now one by one we put the values here. Write down PE is equal to 500 into 10 raised to cube pi square, and the value of this E is equal to 12.5 into 10 raised to 3. We already mentioned in first, and I is equal to B raised to 4 by 12. Okay, and LE is equal to our effective length 2500 square. Now we find out B raised to 4 here, so make a subject. B raised to 4 is equal to, cross multiply this term, 500 into 10 raised to cube into 2500 raised to square into 12. Divide by this term, pi square into 12.5 into 10 cube. Now my B raised to 4 is equal to 303.96 into 10 raised to 6. Okay, here we find out B raised to 4. Now simple, B is equal to 303.96 10 raised to 6 and 1/4. Here we find out value of B is equal to 132.04 mm. Okay, now finally we write down the size of square section right here. Size of square column section, square column, okay, is equal to 132 mm by 132 mm. Now we find out second size, that is for our sigma that given in data. Okay, first of all write down here our second stress is equal to, now second size is for allowable stress, that is mentioned in data, allowable stress, okay, is equal to, this stress is given in example 12 megapascal. Sigma is equal to 12 megapascal. Okay, now what is the equation of stress? Stress is equal to Euler load divided by area. Both values are given here. One by one we write down here. Stress is equal to 12 and Euler load is equal to 500 into 10 raised to cube divided by area. We find out here. Then area is equal to 500 into 10 raised to cube divided by 12. Okay. Now my answer of this area is equal to 41.66 into 10 raised to cube mm square. Okay, and column is square section, so area is equal to B square. Simply write down B square is equal to 41.66 into 10 raised to cube mm square, and under this term finally we get B is equal to 204 mm. Okay, now size of square column is equal to 204 mm into 204 mm. Okay, now from these two sides, first is our 132 and second is our 204. Which one we consider? Wood is our brittle material, so we take more area. So here write down we consider maximum size. Okay, so answer of this column section is equal to 204 mm by 204 mm. This is our final answer. Okay, size of column according to our material. Here we take maximum size. Okay, now we solve our second example. This example is complete. Okay, now in second example, column 1 meter long has a cross section area 9 centimeter square. Okay, and find a slenderness ratio if section is circular. First section is circular, second section is square, third section hollow circular with inner radius half of the outer radius. Okay, relation is given. Here no AND condition is given. In that condition we assume that both end of column are hinged. If in example and condition is not mentioned, simply we assume that both end of column are standard condition. We take both end of column are hinge. Okay, first of all here we write down assume solution of this example. Assume both end of column are hinge. Both ends of column, both end of column are hinge. Okay, now L is given 1 meter. Okay, convert into mm. 1 meter is equal to 1000 mm. Okay, here both end of column is hinge. That means LE is equal to L and that is equal to 1000 mm. Clear? Now area is given. In this example, area is given. A is given 9 centimeter square. Convert into mm. 1 centimeter is equal to 10 mm and 1 meter is equal to 1000 mm. This is the conversion. Okay, so 9 into 1 centimeter is equal to 10. So here we take 10 square. Okay, that is equal to 900 mm square. Okay, this is my conversion of area into mm square. Now one by one we find out slenderness ratio, that means lambda. What is the equation of lambda? Lambda is equal to LE by K. That means here to find out lambda we take LE, that we already find here. Okay, and we also find out K, radius of gyration. And this radius of gyration is depend upon two values, that is moment of inertia and also area. Area is given here, but we find out inertia, but inertia is again depend upon size. So first of all we find out the size of particular section. First we take a circular section. So write down one by one we solve different type of section. First is our circular section. Okay, first of all we find out size, that means diameter. Area is equal to pi by 4 d square. Clear? What is the area of the circular section? 900 is given. 900 then pi by 4 d square. After solving we find diameter d for this case is equal to 33.85 mm. Clear? Second we find out I. So write down here I is equal to pi by 64 d raised to 4. Put the value. Diameter we recently find out, pi bar and pi by 4, pi by 64, and d is given 33.85 raised to 4. And my moment of inertia for this section is equal to 64,447.27 mm raised to 4. Next we find out radius of gyration. So right here radius of gyration, K is equal to under root I by A. Now under I we recently find out 64,447.27 and area is given in data, that is 900. My answer of K for this circular section 8.46 mm. Okay, now next we find out slenderness ratio. So right here what is the equation of slenderness ratio? That is equal to, okay, right here slenderness ratio, slenderness ratio lambda is equal to LE by K. LE is equal to 1000, that is given in data 1000, and this value we find out 8.46. Now my lambda is equal to 118.17. This is for circular section. This lambda is for circular section right here. Okay, this is our first section, circular section. Now second we find out for square section. So right here square section, okay, and square section, here area is given. What is the area of square section? That is b square. So right here b square is equal to 900 and b is equal to under root of this 900 and b is equal to 30 mm. Okay, here we find the size of square section. Now we find out moment of inertia. I is equal to b raised to 4 by 12. B is equal to 30. 30 raised to 4 by 12. And answer of this I is equal to 67,500 mm raised to 4. Mm raised to 4 is the unit of this moment of inertia. Now we find out radius of gyration. K is equal to under root of I by A. Now I we recently find out. I is equal to 67,500 and divide by area 900. And my K, radius of gyration for this rectangle section is equal to, square section is equal to 8.66 mm. Okay, now we find out slenderness ratio. What is the equation of slenderness ratio? Slenderness ratio lambda is equal to LE by K. Now one by one put the values that we find out. Lambda LE is equal to 1000 and K we find out 8.66. After dividing, lambda for square section is equal to, we find out 115.47. Okay, lambda is a unitless quantity. This is the for square section right here, square section. Okay, now next we find out our third section, that is our circular section. First of all, condition is given here for this circular section. Third, hollow circular section right here, hollow circular section. Okay, hollow circular section. And in this section, inner radius R is half of the outer radius. Now what is diameter? Diameter is equal to capital 2R. That means R is equal to, here we can write that D by 2. Okay, we write same condition for small r. Here we write down small d by 2. Okay, this is the relation of radius and diameter. So in replace of R, here we write down d by 2 and 1/2, and this R is equal to capital R is equal to capital D by 2. Ultimate my relation is small d is equal to, this 2 cancel, 0.5 capital D. Okay, because here we find out unknown values in form of diameter. Now what is the area? Area of this hollow circular section is equal to pi by 4, then d square minus d square. Clear? Now one by one we put the values. Area is given 900 and pi by 4, then capital D square, and small d is equal to 0.5 capital D whole square, and complete. Okay, and after solving 900, then pi by 4 d square, and here 0.5 square set means 0.5 square and d square. And after solving this, okay, now we find out our value capital D, and this capital D is equal to, write down, capital D square is equal to 1527.87, and after under root capital D is equal to, we get 39.88 mm. Okay, now next we find out small d. Small d is equal to 0.5 capital D, that is equal to 0.5 capital D, we find out 39.88, and that is equal to 19.54 mm. Okay, now we find out inertia. I is equal to pi by 64 d raised to 4 minus small d raised to 4. Okay, pi by 64 d is equal to 39.81 raised to 4 minus 19.54 raised to 4, and my inertia I is equal to 107.42 10 raised to cube mm raised to 4. Clear? Now we find out radius of gyration, and radius of gyration K is equal to under root I by A, and my answer of this radius of gyration after dividing 10.92 mm. Okay, finally we find out slenderness ratio. Lambda is equal to LE by K. LE is equal to 1000, so right here 1000. K we find out 10.92, and after dividing my answer is equal to 91.53. Okay, so final answer lambda is equal to 91.53. okay, this is for our hollow circular section. Okay, hollow circular section. Okay, now here our example is complete. In next session we solve the another type of example, I section and hollow rectangle section. Just now we complete here.